Hi, everyone. Welcome. This is another episode about Microsoft Fabric data engineering. And today I'm going to talk with Santhosh about the fundamental topic, which is security in Microsoft Fabric in the context of data engineering. Santhosh, thanks for joining us another time.
Super happy to be back on Fabric, Esther. So thanks for having me, Esther.
Awesome. So I want to start with just a perspective. So Microsoft Fabric is a SaaS tool, software as a service.
Yeah.
We anticipate SaaS tools like the applications for, again, Fabric is for processing big data in the era of AI. At the same time, why we should dig into security knowing that it's a SaaS tool? So shouldn't everything be packaged inside the SaaS box?
That's a very valid question. And yes, it should be, and it is. So the workloads in Microsoft Fabric are secure, and you get like security by default in all cases. In this topic, this becomes super critical because security is basically a defense in depth concept, right? Where you would want to make sure, and each and every organization or enterprise would have different use cases, and they would be dealing with different sets of data, different levels of criticality, and based on each of these, they would want to ensure that the data is protected on different levels. Some in terms of access, some in terms of accessing inbound or outbound scenarios where they're blocking traffic. And it also applies based on the domain in which these enterprises are operating. Like financial customers have a lot of regulations and a lot of access policy enforced to make sure that the data on different layers are safe and encrypted and secure. Fabric, as you mentioned, is a SaaS tool. It's for everyone, every enterprise to run their production workloads at scale. But we also want to make sure that different tools are available for all of these enterprises so they can actually pick and choose which would apply well to block all the threat vectors that they foresee for running a secure data platform.
And yeah, if I read you correctly, and also integrate with data sources in a secure way when the data is not going through the public internet, but going through the Microsoft backbone, so the internal Microsoft network.
That's correct. I mean, all of the traffic that's in the network layer, 100%. All the traffic, of course, goes through the Microsoft backbone public network, and it's not through public internet. But there are additional capabilities which we have announced in the recent months, which users can apply on different levels to further isolate their workloads. And again, Fabric, as you know, is comprising of multiple engines like data engineering, data science, Power BI, real-time intelligence. All of these workloads are different in different aspects. Data engineering, in this case, which we'll be like diving deep on, is much more critical because it allows users to run untrusted code, where users can run arbitrary user code, which is generally untrusted from an enterprise security perspective, because they could basically have any event listeners knowing, or they could be importing public libraries which may not be approved by enterprise security teams. So enterprise admins would want to make sure that they have all of these controls in place. So the data, anyone who's accessing and also running these data engineering workloads on their data is accessing through secure channels. When they are accessing the sources, they're accessing them in a secure manner and also running the jobs in a more secure way. So on different levels.
Makes sense. So I have tons of questions, and I would love to understand, starting from security by default in Fabric, also going through workspace identity. I have a few questions about billing, but maybe let's start giving you the stage. You can educate us, and then we can have a discussion and pop quizzes about security in data engineering.
Awesome. Sounds good. So security is multi-layered. And when we're talking about data engineering today, you have different layers, and we will be double clicking on like each of these concepts and what are the different tools and options that you have in Microsoft Fabric to further isolate your workloads. So first one is the outermost is the network. So in this case, it is both ways, right? It comprises of all the network traffic coming into and going out of Microsoft Fabric. The next one is workspace and item level. So as you know, when an enterprise team onboards to Fabric, it's at the tenant level, and each and every team, they create a capacity in Azure. The capacity is regional. They could select an Azure region where they would want this capacity to be provisioned, which provides the compute for all of the workspaces. They create workspaces, and they could use different levels of access roles to allow users, to give them permissions to modify items, to modify settings, to modify configurations which would have an impact on their security and building aspects. And again, at the artifact level gives them further level of control to block users or permit users to view and edit items like lake houses, which is going to be a front door for one lake for accessing your data. Next is the data security. So OneLake has a set of features which allows Fabric data engineering workloads to honor, and when they run these jobs, users are able to honor the access roles provisioned by the data source owner. So if I'm an enterprise data lake owner, I have data product teams who are connecting to my data source, I would be able to provision access for them, and these access roles allow these users to only see the files or tables that they have access to. Next is the interesting part where you run the arbitrary user code, which we talked about a while back, and how secure it is and how they could actually make it more secure. This also ties into other aspects. So you could see an arrow pointing to a data source outside. So if most of the cases, in the case of data engineering workloads, users are trying to ingest data from their cloud or on-prem sources, and when they're bringing in the data, they want to make sure that their credentials, which is the most critical thing, are secure when running within a Spark cluster, and security at the runtime level, and how they could actually access these in a more secure way with all of these controls is what we'll be seeing. So let's dive right in. Network security. For data engineering workloads, the network security is offered through managed VNets. And Fabric being a SaaS solution, we don't expose like other past products where users will be able to create their own virtual networks. Whereas in this case, these are called managed virtual networks because these are provisioned on behalf of the customer's workspaces. So whenever a user enables a tenant level private link, or when they create managed private endpoint connections. So private link is for the inbound access. So in this case, from a customer VNet, they want to access Fabric, like they have a private network set up in their enterprise. Say it's a company A and they have set up all of this network infra. They want to enforce this policy where they would only allow the corp net computers in the corp network to access Fabric. Then they have an NSG rule set up. Then in those cases, users, if they're trying to access it from Starbucks or any other cafe or from their home, they'll not be able to access it. So this block provides the inbound connection, and that uses a tenant level private link concept. And when that is enabled, all the Spark jobs, all the data engineering workloads or lakehouse operations that they do is done within an isolated managed VNet, which is provisioned by Fabric for the workspace on behalf of them. Now, the outbound. So this is where they connect to external data sources. In this case, it's more granular at the workspace level. Users can go to network security settings in the workspace. They could create a managed private endpoint. Once a managed private endpoint is created for a workspace, the network isolation boundary is offered through a managed VNet. A managed VNet is provisioned for a workspace, and all the compute that gets spun up based on the jobs that are triggered within the workspace are running in this isolated network. So in this case, we have 20 plus sources that we support as part of managed private endpoints. Users will be able to create these, and once created, they will be able to run their notebooks and Spark job definitions within the managed VNet. The next layer, you have these complicated scenarios. I mentioned about an existing network infra that a company could leverage. And the other one is users have data sources where they're accessing it through managed private endpoints. Now, simplifying it by one step further, say I have a data source, like a storage account. I don't have a managed private endpoint for my workspace. I don't want to create a managed private endpoint for a workspace, and I don't have any tenant level rules set up. Trusted access using the workspace identity provides a much more easier solution for scenarios where users can actually enable this workspace identity from their workspace settings. Once enabled, Microsoft Fabric becomes a trusted service on the Azure control plane. So users will be able to select from their storage accounts networking page and allow list the Fabric instance either within their subscription or resource group or the entire tenant. They could select the scope. Once that is done, they will be able to access the tables or files in the data lake gen 2 storage account through one lake shortcuts, which we could consume through Spark jobs, like through Lakehouse items, as you know, and also through data pipelines. So let's look at it with an example. In this case, a data is stored in a ADLS Gen 2 account, and storage account is blocked from public access. So in this case, the storage account is only accessible from allowed listed traffic. So I go to the storage account. In this case, this is my sample storage account. In the networking tab, what I do is I navigate and I search for Microsoft Fabric workspaces and I enable it or allow list it on the storage account. Once that is done, I would be able to access. I've created my workspace identity for my workspace, and now I've also added the workspace identity to the folders that I need access to. The setup is done. In this case, if you look at it, I actually have a lakehouse. So I go to the file section, I create a shortcut. As part of the shortcut creation, I create a new connection. I specify the storage account that we saw a second ago. I'm using the same storage account. I go to the containers, I get the properties or the path, and I try to connect to it. When I'm actually connecting to this, you can see that with few clicks, I'm able to access a secured storage, which is blocked from public access, and I'm able to shortcut to the folder that I have, which is a sample data that I see here. Now that you can see that the data is already available in the Lakehouse as a shortcut, I could immediately start running Spark jobs, and users can get like a Spark session like within 5 seconds. You can see in this case, the session start experience is going to be almost instantaneous, and the job runs, and you can actually see they are able to access the files from Fabric without adding any other network rules on the Fabric side. In this case, it's all they're doing is they're just allow listing the workspace identity. Now that we touched upon the network side, going one level deeper, in this case, it's the workspace and artifact security. So as I mentioned, Fabric is going to have like multiple capacities. Workload teams or an enterprise organization could have multiple capacities which are associated with multiple teams, and they could have multiple workspaces within that. Now, within the workspace, users can add an admin role, member, contributor, or viewer. So, as a workspace admin, I would be able to permit users to view or manage assets or items within my workspace. Going one level further down, this is at the entire item level or the workspace level. Using one lake access roles, which was recently introduced, users would be able to specify a role for a specific table in a lakehouse. So as part of the lakehouse experience, you actually see this tab called manage one lake access. And in this case, you could specify the tables and the folder paths. And after you created a role, you could add users from your organization. So in this case, you can see that I'm actually specifying a role, and I specify the user accounts that I would want to add as part of this. Once that is enforced, if another user is trying to run a job querying this file path, they're not going to be able to read it. It's only going to be allowed for users who are allowed listed at the access layer. This is more on the data plane level. So we saw what is available at the network level. We are now seeing what's available at the data level. Now comes the fourth or the final part, which is more in terms of the runtime. And say you're accessing a data source. You would want to make sure that you access the data in a secure way. And when you're accessing data, you would also want to make sure that you are handling the secrets in a secure way. MS Spark Utils is a library that we ship, as you know, and it allows you to connect to Key Vault, and you also have this client secret credential method to which you can pass a service principal ID and also the reference through which you'll be able to access and acquire tokens for accessing the secret. And once that is available, you're now going to be able to access storage accounts or other files where you've actually allowed listed this SPN with a reader role, contributor role, which has access to access this data. So now we saw what's enforced on the network level and at the workspace level, and then at the data plane level. Now let's look at it from the end to end, like at the last layer, which is the runtime level, which includes all of these and which honors all of these restrictions or policies that have been set up. So let's take an example, right? So in a typical workload, in an enterprise scenario, users would want to connect to a data source, which is sitting behind a firewall, not accessible to a public internet. And to connect to this, they would first want to like make sure that they have a secure channel. That could be done using the different approaches that we talked about. In this example, I'm going to take an example of like managed private endpoints, which is going to be offering a secure channel from my Fabric workspace and its managed VNet to the data source in cloud. The next one is to access this account or this data source, I would need a valid credential. So there comes this interesting part of like credential management. And the credential management is very critical for Spark because in this case of data engineering workloads, given that they have this nature of allowing users to run arbitrary user code, which is considered to be untrusted by enterprise security teams. You want to make sure that your secrets are not exposed or leaked at any point in time. So you cannot like hard code your secrets in your notebook or your Spark jobs. So using MS Spark utils in this case, what I'm going to do is I'm going to refer to a key vault, which is going to have the secret. That's something that I'm going to use for accessing using an SPN, which is given an data reader role for my remote storage. So as a first step, I would actually have to configure the managed private endpoint. And once the managed private endpoint is configured, so the creation of managed private endpoint is going to be simple. In a second, I think I should be able to show that in the GIF. So users would be able to go to workspace settings. So in this case, say first I'm running a job, it's showing as forbidden. I go and create a managed private endpoint. I create a managed private endpoint by giving a name, specifying the resource provider and the target resource. So in this case, I'm actually creating two managed private endpoints. One for my key vault, where I have my secret, and I can see that my managed private endpoint request has been already surfacing up as part of the key vault. I go and approve it. Another one to my storage. I specify an access justification for approving this access request. You can see that once it's approved, I go to my notebook. Now I add the code stubs for accessing the storage using an MS Spark utils. So I use MS Spark utils, connect to the key vault, get the client secret, use that to read the file path from the storage account. You can see that the job runs. So in this case, both my storage account and key vault is behind a managed VNet, and I'm accessing it through secure channel. And then I acquire my secret in a secure way where I'm not exposing it during my runtime execution, and I'm using that to access it for fetching my data. As you had asked in the beginning of the call, security is like offered out of the box and by default. So as you know, the model in which Spark in Fabric operates, it's always going to be one user, one cluster. There's not going to be any instance where multiple users could run jobs on different clusters. So the user isolation, network isolation is both offered by default, and in this case with added network boundary as part of managed VNet should provide the tools which enterprises could actually leverage at different layers for running a secure data platform.
That's awesome. So we have multiple different layers, starting from network, then through different layers of software-based, or runtime-based, data-based. Again, here we can, I think that share that we are also working on RLS, CLS. So the next level, the next milestone for bringing the object level security for our customers. So on top of that, candid question.
Yeah.
What's the billing story? Knowing that in the past we had an announcement situation when we said that the restriction for specific security network-related features is based on the premium and defined SKU?
Yeah, no, it's a very interesting question. And yes, when we went public preview, we had this restriction for the network features, the security features, like in this case, managed private endpoints and workspace identity, were only allowed for SKUs that are F64 and above. But we heard a very good amount of feedback from community and also our users. So now it's been since it went GA, the features have been available for all SKUs. So any Fabric F SKU, be it an F2 or F4, all the way up to like F20, 48, you would be able to access this network security tab, create managed private endpoint connections. So it's not restricted to any premium SKU. And going back to your previous question in terms of billing, the billing is not currently enabled for these features, like in terms of managed private endpoints. So it's coming, but all the workloads that they're using currently, it's been GA since I think we went GA in July, if I remember correctly. All the workloads that are running, they have not been charged. It's yet to be implemented, but that's coming soon. And it would be similar to the model that we had where we charge for the private endpoints, but currently it's not being emitted. It's coming soon.
Got it. So the key topics, the key features that we have to know is private endpoint, workspace identity, key vault and integration with MS Spark utilities, and however this library is going to be named. Anything else?
No, I think, and you also touched upon the one leg access policies, right? So at the data plane level, so different layers. So
Yes.
network security is from like private links and managed private endpoints, inbound for private links, outbound for managed private endpoints. Data plane level, one leg access policies. At the runtime level, all of these are honored, and also you have additional capabilities on like securely accessing them through managed VNets for your Spark workloads, and also credential management in a more secure way using notebook utils or like MS Spark utils, where you would be able to specify connection properties to your key vault and you access them in a secure channel and acquire the tokens. The token is secure. It's not going to be exfiltrated because it's going to be always within your user boundary, your dedicated network, your dedicated cluster.
Awesome. So now, question from a very different side. So let's recall the physics. So the physics is that our data centers are distributed across the globe.
Mhm.
And those data centers are connected with Microsoft Backbone internet connection.
Mhm.
And that connectivity, let's assume, and let's say that, again, this is a private to Microsoft, meaning that if I'm querying a data here from US and my data center, so that storage account is located in Australia, then the internet, I'm again asking sending the request, but the data is coming between those data centers. If my compute is here, through the backbone network. So it's obvious that there is some network latency. Right? Because we have to transfer the data under the ocean. So in case of those extra steps on the different layers, especially on the network layer, what's the impact? Do we have any benchmarks that we can share or a thumb rule, how that works and how that impacts our performance?
Got it. No, a very valid question. So let me answer it. Like there are different options that we talked about. So let's take the managed private endpoints or like private links. So for data engineering workloads, you know that everyone loves startup pools. They are a very special offering for Microsoft Fabric, where you get like a 5 second session start experience for your notebooks. You don't have to wait. But currently, for workspaces that have actually enabled managed private endpoints or tenants that have enabled private links, the startup pools are disabled and they have to go on demand. So that adds the session start latency of 3 to 5 minutes. The reason being, again, this is something that is a current limitation. We are working on multiple other solutions to like offset this. But currently, what happens is startup pools are are hosted as part of like a shared VNet. It's a multi-tenanted one, right? We manage those compute. But for users who are asking for dedicated network isolation through managed VNets, we provision a dedicated managed VNet. So these clusters are spun up or allocated within those dedicated networks. So that adds to that latency. This is the first one. There are multiple ways users can offset this, right? Using high concurrency mode. Given that high concurrency mode is also within the same user boundary, users can start a high concurrency session. Say, for example, and being pretty candid about this, right? Say I'm an enterprise customer. I have a job that needs to complete within 9 minutes. I cannot pay for the 3 minute session start time because that's going to break my SLA. In these cases, what we could do is one workaround that I would think of is like use high concurrency session, like from pipeline, enable it. High concurrency session is going to go on, and say my tenant level private link is enabled, or I'm connecting to a managed VNet through a managed private endpoint. I'm losing my startup whole experience. So what I do is I start a session, I enable pipelines, high concurrency mode for pipelines. I run a notebook, I acquire a session. The first one is going to take the hit, but that could be just a session acquisition notebook. Then what I do is I add my other notebook step, which is going to run the code for my job, like which needs to complete within 9 minutes. So in that case, that's going to get immediately packed into the existing active high concurrency session. And this for high concurrency session, as you know, we just create a repo. So that just comes up in like 5 seconds. So you're going to get the 5 second session start experience and you could run the job. And in this case, given that it's a shared session, you're not going to be wasting additional compute on again, this is a workaround, but we do have to like solve for that. But I'm just giving, like, I've come across this scenario in like multiple Twitter conversations or on Reddit. So I'm just putting it out there. So folks who are watching this video could actually benefit out of this. But there are multiple other approaches where you could offset this. This is one of those. So we touched upon the session start latency. The other latency in terms of cross-region access. The cross-region access is going to be with or without this network isolation, right? Because ideally, you would want to make sure that you are not doing a cross-region read or cross-region writes frequently, because you're going to have like bandwidth limitations. You're going to have like overall your IO cost, or in terms of compute or performance, is going to be higher because it's going to take longer for you. And that is something that happens all the time when you communicate across, like, say, so you mentioned from United States to like Australia. It's like a completely different geo. So choosing a primary region and provisioning your fabric capacity or compute in that primary region, so that you make all of your calls to your data sources local, should help address that. And that's how usually enterprise teams also design their infra or manage their infra, right? So that it's, and of course there are like BCDR scenarios where you would want for business continuity reasons, you want this to be replicated in another geo. But your primary region is where you have everything more accessible, and you're avoiding the cross geo queries or like frequent reads if you're doing. Other than that, on the Spark layer, one other approach that I would talk about, I also mentioned this earlier in this discussion, is trusted access. Using trusted access, you get startup whole experience. You get this same level of network protection because you are allow listing the Fabric workspace identity. So that should, if you're only trying to connect to storage accounts and not to any other data sources, then that should give you a faster session start experience and also the network isolation that you're looking for. So these are a couple of options, but yes, it's always going to be a trade-off, right?
At least we can guide everyone to be always sure that the compute is located in the same region where the storage. And if there is any need of doing cross-region calls, for example, through shortcut, customers love shortcuts,
Yes.
right? But we need to be aware, if you are doing a shortcut to one local ADLS Gen 2, which is in a different region, then there is always be the physics rule applied.
Yeah, exactly. Yes. That still applies, and that holds true even in this case. But other than that, I think these are the possible additional hops that would be created, which could impact the overall job duration or like add to your latency.
Yes, and from the other side, we have a caching machine for shortcuts. We have
Yes,
caching.
that's true. Yes.
For Spark Runtime, we also have caching, but on a very different layer.
Yeah.
So it's enabled by default intelligent cache
Yes.
working for you. But this is kind of a mitigation. Great, Santhosh, thanks a lot. That was an amazing portion of the knowledge we consume. Now we have to digest all of those different layers to enable extra security for every data engineer. But the same rules applies for every data scientist because that experience is similar. So for those who are watching us, please remember to share a comment, leave the like button, subscribe the channel, because this is what feeds us and also motivates to record those episodes, is just to share the knowledge and the insights with you. And until the next time, happy exploring with private endpoints, with workspace identity, and with tons of different security related features. Thanks a lot.
Thanks, Ashra. Thanks, everyone.